Okay, good morning class. Actually afternoon, but anyway. So at this point we're looking at simultaneous equations, which is chapter 8.
Mr. Bodji, I'm so sorry to interrupt your lesson. Aisha Sali, can you please send it to the office?
With the bags, miss?
No, sir. Just for 1 second.
Okay, no problem. 1 second is over. Right, but anyway, let's go. People, simultaneous equations is chapter 8. Simultaneous equations are two equations. So we are told that simultaneous equations, which is x and y, in two equations we need to find x and y which satisfy both equations. It is the point where the graphs of two equations cut one another. Okay? Important to note that the first equation has one unknown, which is x. The second equation has two unknowns, which is x and y, or vice versa. Method 2. Use first equation and make the variable x or y the subject. Now substitute x or y into the second equation. Let's look at example 1. Example 1 is on page 83. Example on page 83. That's 19. 83. So the question says solve for x and y if x plus 2 is equal to 0 and x minus y is equal to 3. So you see we got x plus 2 is equal to 0. Okay? And this is, we named this equation 1. And then we got x minus y is equal to 3, and this is equation 2. Okay. So what did the note say? The note said you must solve for x in the first equation. Or you're going to solve for x in the equation that has one unknown. Can you see that, people? And which equation has one unknown? Sorry? Equation 1. Can you see that, people? So what we do is, we solve for x, no? We take it over the equal sign. This is now from equation 1. So if you take x over the equal sign, what does this now become? X is equal to minus 2. Not so. What are you looking for, Michael? You don't need the paper now. Because when I'm done with these examples, and then you might or might not find the paper, and then you're confused. So please take note. Not bother what we do. Are you all okay with this? So what I did was I took the first equation and I solved x. Because there is one unknown there. Okay, you guys all understand. So what we're going to do now is we substitute this x value into equation 2. If I substitute x in, what will I solve? 1. Can you see that, people? So now we're going to substitute x is equal to minus 2 into equation 2. Okay, so whenever I see x, I put a minus 2. So minus 2 minus y is equal to 3. Minus 2 minus y is equal to 3. So what I do is I take this over the equal sign. So minus y is equal to 3 plus 2. And what's 3 plus 2? 5. I get y on its own. What do? Divide both sides by negative 1. So y is equal to negative 1. And we can test if our answer is correct. We put here minus 2. So x is minus 2. So minus 2 minus minus 5 will become plus 5. Minus 2 plus 5 is 3. X is minus 2. Minus 2 plus 2? 0. So it works. You guys understand? Let's do it again. Let's go again. Did you find what you're looking for? You're still looking. Oh, you found it. Okay, nice. So we listed two equations. The one is x plus 2 is equal to 0. And this equation 1. And then we got x minus y is equal to 3. And this equation 2. Which equation has one unknown only? Equation 1. The first equation. Okay? So from equation 1, solve for x. You take it over the equal sign. So x is equal to negative. So now x is solved. So what must still be solved? 1. Remember that the x in this equation is the same x as in that equation. You see that, people? So what is x? So minus 2 minus y is equal to 3. But what did we say before this? The same what we're doing. We'll substitute the x value of minus 2 into equation 2. Why don't I go with equation 1? Because there is no y. Okay, you guys understand? So if I see an x, I put a minus 2. So what is now going to read? Minus 2 minus y is equal to 3. Now it's just a matter of solving for y. They get over the equal sign, so negative y is equal to 3 plus 2, which is 5. Divide by negative 1 throughout. So y is negative. Okay. So when they spoke about graphs, if I must sketch this graph, how do we sketch a graph? X-intercept, let y equal to 0. Not so. So x-intercept, let y equal to 0. So x is equal to 3. Y-intercept, let x equal to 0. So y is minus 3. So that is what that graph is going to look like. Okay. And then right here. Alright, and if I must draw now the other graph, which is x plus 2 is equal to 0, that is the x is equal to minus 2 graph. Not so. So it's a straight line at minus 2. So there is that graph. Okay. So you see where these two graphs meet, this is actually the point, minus 2 and minus 2. You see my graph is not drawn to scale, but it's clear that that point is correct. Does it make sense, people? No? But don't forget, I will show you in the next graph, in the next equation, the same thing, where it intersects. Okay? So to calculate the points of intersection, or where the graphs meet, is also the simultaneous equations that needs to be done there. Okay. Let's go to number 2. Example 2. Example 2 is on page 84. Is Rudolph leave for England already? Is he sick of us? Oh, not of us. Okay. Give an example 2. Solve for x and y. So we got equation 1, which is 2x minus 5y equals 4. And 2y minus 4 is equal to 2. This equation 1 and equation 2. Right. Which equation has one unknown only? Equation 2. Equation 2 only has a 1. Not so. So from equation 2, what can we say? We're going to make y the subject of the formula. We take that over, gives us 2y is equal to 2 plus 4. What's 2 plus 4? 6. Divided by 2. So y is 3. Okay. So what do I do now? We'll substitute. Y is equal to 3 into equation 1. Why not 2? Because there is no x here. It makes sense, people. So let's do the substitution. What do we get? 2x. Remember, if I see a y, I'm going to put a. If I see a y, I'm going to put a 3. So I got 2x minus 5 times 3 equals 4. So what I just did, if I see a y, I put the 3. So it's 2x minus 5 times 3 equals 4. So what do I do from here? Solve for x again. So 2 times 3 times 5 is 15. You take it over the equal sign. So 2x is equal to 4 plus 15, which is divided by 2, which implies that x is equal to 19 over 2. 19 over 2 is also equal to what? 9,5. No? Or 9.5. Just to put that in perspective of what that actually means. If I draw this graph here, I'm actually going to draw this graph. 2y minus 4 equals 2 is actually the y is equal to 3 graph. No? There's 1, 2, 3. So this is the y is equal to 3 graph, which is 2y minus 4 is equal to 2. And then if x intercept, then y equal to 0. So that is going to give you 2. Y intercept, then x equal to 0. So that is minus 4 over 5. Minus 1 is there, minus 4 over 5 is approximately here. So, sorry, there. That is actually the point I wanted to mark, okay? So, if I draw this graph going through like that, can you see this point here is actually the point of contact? Can you see that, people? And does it make sense? Would this be approximately 9.5? Yes. 9.5. And the y value of 3. So that is actually that point that we have calculated. Does it make sense? Okay, we don't have much time left, so I'm just going to do the third one. I'll post the video shortly. By 3:30 the video should be posted. You can watch it again, okay, if needed. Need be. However, on Monday, I'm going to do all the odd numbers of this exercise on the board. I'm going to do the recording of that as well, okay? So, I know I don't want to make the video too long, and we know it's almost the end of the day as well, okay? But anyway, let's do this quickly. So we have two equations. We got 2 into x minus 4 equals x minus 2. And then we got x minus 2y plus 4 is equal to 0. This is equation 1 and equation 2. Right. Sorry? Okay, so equation 3, we got example 3, sorry, on page 84, we got 2 into x minus 4 is equal to x minus 2, that's equation 1, and x minus 2y plus 4 is equal to 0, equation 2. People, which equation of the two has one unknown? Equation 1. Equation 1 pertains to has x's only. Not so. So what do I write here? From equation 1. What can we say? We get rid of this bracket here. Not so. So what do I write here? 2x minus 8 is equal to x minus Now what? X is one side, numbers the other side. So we've got 2x minus x. See, is it like an equation? Huh? Exactly an equation. 2x minus x is equal to minus 2 plus. What is 2x minus x? X. What's minus 2x plus 8? So there I got the value for x. Okay. So what do I do now? You'll substitute x is equal to 6 into equation 2. So wherever I see an x, I replace it with. You see that, people? Now what? 6 minus 2y plus 4 is equal to 0. Okay. So minus 2y, what is 6 plus 4? 6 plus 4 is 10. If I take 10 over the equal sign, becomes negative 10. Okay, 6 plus 4 is 10. If I take 10 over the equal sign, becomes minus 10. So that implies that y is equal to? Y is equal to? What? People, and we can test it. Okay? If x is 6, what is 6 plus 6 minus 4? 2. 2 times 2? 4. So 4 is on the side. No? Put 6 in here. 6 minus 2? 4. So that one balanced. So number 1 is in order. Let's go with example with equation 2. This is 6 minus 2 times. What's your y value? 5 plus 4. What's 2 times 5? 10. 6 minus 10 minus 4. Minus 4 plus 4? 0. So both. So that equation is correct. The solutions are correct. Again, if you draw these two graphs, what will happen? The two graphs will intersect at the point of 6 and 5. Remember, this is always an x and a y. Can you see that, people? So the ends, x is 6 and y is 5. You guys understand? So for homework, there are 10 sums. I want you guys to do all the odd numbers first. If you have an issue, you can't solve it after you checked it as I showed you, then you leave the second 5. Then you leave the even numbers. If you solved all 5 and then you had no problems, you do the even numbers. Okay. On Monday I'm going to do the odd numbers on the board as well as the homework of graphs. Okay. Yes, Michael. Sorry? Unless she asked, do we have to draw this on the graph? And the answer is, of course, no. Unless the question asks us to do it on the graph. Okay. If it says, calculate the point of intersection, or illustrate your answer on a number line, on a Cartesian plane, or in graph format, then we do it graphically. Yes, Michael? Sorry? From equation 1 and so on. For now, do it, and then later on when you're comfortable, you can drop it. Okay. But there's no marks allocated from equation 1 and labeling the equations. Later on, you're going to just see me draw arrows. Okay. But first, make it a habit of having equation 1. And so, when somebody else explains equations going of 3 unknowns and 4 unknowns, then we have no choice but to label it. Not because it's worth marks, because if we're not going to label it, it's going to cost us. Or we're going to make a mistake easily without labels. Okay. So it's going to be better for us to label. Okay. The full lesson can be found in the description box below. Yes.